In this podcast, we're going to be looking at rational functions where we could reduce first. So solving these problems is easier if you factor first when it allows you to cancel a factor and reduce. Remember, cross-reducing is not allowed when you're solving a proportion, but you can cancel within a fraction, within numerators, or within denominators. Let's look at the first one. Okay, so this one's in your notes. We have 2x divided by 4 minus x equals x squared divided by x minus 4. Okay? And we actually have a couple places we could factor. There's the most obvious, so I think we will take care of the most obvious, because I don't know that you'd see the other one, and I'll show the other one later. All right, so the most obvious one is in the numerators. Remember, we can reduce within a fraction. There's nothing we can reduce within each of the fractions because there's no like factors. We can reduce within a denominator, and we can reduce within a numerator. And if you notice here, this 2x is 2 times x, and this x squared is just x times x. So both of those have a factor of x, just an x. Right? So we can reduce an x from both of those. You couldn't reduce an x, for instance, from the x minus 4, because that factor is not x, that factor is x minus 4. Right? So if something is added or subtracted, it's a whole factor. But here we don't have anything added to x, it's just 2 times x. So I can cancel an x in both the numerator and the denominator. And if we do that, we're going to be left with a 2 in the numerator divided by 4 minus x in the denominator equals x divided by x minus 4. All right, so now we can cross multiply and distribute and reduce. All right, so we're going to have x times 4 minus x equals 2 times x minus 4. Don't forget your parentheses, and don't forget to write the step down so you remember to distribute. All right, so we'll distribute. We have 4x minus x times x is x squared equals 2 times x is 2x, and 2 times 4 is 8. We need to get everything on one side. Since x squared is already negative, let's subtract the 4x and add x squared to both sides and move them over here. Oops. That's supposed to be an x squared. All right, so over here now we have 0. On the other side, let's put this in standard form. So the x squared should go first. And there's no other x squared, so that's it. We have a 2x and a minus 4x, so that's going to be a negative 2x, and we have a negative 8. All right, so now we can solve. We're going to factor each side, and then we'll set our factors equal to 0. So 1 times negative 8 is negative 8. We need 2 numbers that multiply. Let me actually move this up a little bit to give us negative 8, and add to give us our b term of negative 2. And now I can't hear you all telling me, but hopefully you're all saying negative 4 and positive 2. Those would be the 2 numbers that multiply to give you negative 8 and add to give you negative 2. So we have 0 equals x squared minus 4x is a group, plus 2x minus 8 is a group. And from the first pair, we can factor out an x. We're left with x minus 4. From the second pair, we can factor out a 2, and we would be left with x minus 4. So one factor is what we pulled out, x plus 2, and the other factor is the repeating x minus 4. So if we set those equal to 0, x plus 2 is 0. X would equal negative 2. Somehow my negative got lost in my 2. There we go. And if x minus 4 is 0, x equals 4 is our second solution. So now we have to check out our 2 solutions and see if either of them work. I don't remember if I left space on the next page, so let me just check real quickly. And I did leave space on the next page. All right, so let's check our solutions. I actually have them all typed up, and they might be in your notes already typed up too. All right, so here, actually, I'm going to move the screen this way. So let's look at one solution at a time. All right, so if we plug in the negative 2, all right, so, oops, let me get rid of that one. All right, so if we plug in the negative 2 here, we have 2 times negative 2 divided by 4 minus negative 2 equals negative 2 squared divided by negative 2 minus 4. And so now we simplify. 2 times negative 2 is a negative 4 over 6 equals, and now on the other side we have negative 4 over 6, which is negative 2/3 and negative 2/3. So that solution checks. Right, so actually I'm going to get rid of this. And I'm going to go over something else. Whoop. Now, we learned a little lesson here, and that is when we cancel out x from a numerator. All right, so on the other side here, we times 4 gives us 8. 4 squared is 16. Who cares, because the denominators have zeros in them, so that's not a solution. We're undefined when x equals 4. But if you cancel an x from the numerator, check to see if x equals 0 is a solution. Sometimes it is. So in this case, there were 2 solutions. And once in a while it happens, and actually it only usually happens with a 0. It won't happen anywhere else. But sometimes if you cancel out the 0 ends up being, the 0 ends up being a solution. So anytime you cancel out an x out of the numerator only, if you cancel out an x from the numerator and denominator, you don't have to worry about it. If you cancel out an x from the denominator, you don't have to worry about it. But if it's from the numerator, once in a while, x equals 0 is a solution. So there actually were 2 solutions here. It was x equals, what was it, negative 2. Oh, actually I wrote 2 solutions already. And x equals 0. So be careful on that one, although actually it wasn't a bad idea to cancel out the x. It just works out that way, that x equals 0 is a solution. Now the one that you could have canceled out, and it would have it's the extraneous solution, is if you had switched these 2 terms around, so you had negative x plus 4 and factored out a negative 1, you now have x minus 4. And you could cancel that out of the denominator, and that was an extraneous solution anyhow, not a good solution. If we didn't end up pulling that, by the way, that factor of x out, we would have had a cubic to solve. So this is what happens if we don't pull it out. All right, so I'm going to actually give us a little bit, let me see, do I have any space over here? All right, so this is if we don't reduce. And reducing is not a requirement, but sometimes it makes the problem a lot easier. And it was easy enough to check about x equals 0. If we don't reduce, we end up with 2x times x minus 4 equals x squared times 4 minus x. And you see we're going to end up with something cubic. So this would be 2x squared minus 8x equals 4x squared minus x cubed. If I move everything over to the other side, right, so I'm going to move the 4x squared and add x cubed to both sides. We end up with x cubed minus 4x, minus 2x squared. And who else moved over here? Minus 8x. He was already over here. Equals 0. And so now you see we could factor out the x, and the rest of it is the exact same thing as we have over there. So it's just x minus 4 and x plus 2. All right, and see x was a factor, and that one actually works because that solution is x equals 0. So it makes it for a little bit easier problem to solve if you simplify, but watch out on canceling x out of the numerator. I wanted to show you what happens. Sometimes it ends up being a solution. So all you have to do is you can still reduce. Just make sure if you get 0, if you canceled out an x, just double check that 0 doesn't work. And here you can see 0 works very nicely because you have 0 equals 0, and it's not 0 over 0. So, all right. So if you don't reduce, you end up with something cubic to solve. However, you don't lose one of your solutions. So be careful when you're reducing those x's. If it's just an x out of the numerator, I just want to say it one more time. Just check that 0 is not a solution. and because it was. All right, but you can also, if you notice that those x minus 4s were the same, that was our extraneous solution. So you could actually reduce these by making this a negative x minus 4 with no worries, because that wouldn't have affected our solutions at all. So matter of fact, this would just cancel out completely, and this would just be now a negative 1, and so I'd have x squared times negative 1 equals 2x. And that's something that's really easy to solve. So I'll just subtract x squared from both sides. So we have 0, or add x squared to both sides. 0 equals x squared plus 2x. Factor out that x, and you have x plus 2. And that actually was our two real solutions, x equals 0 and x equals negative 2. So the best factor reducing was the one you probably didn't notice, the denominator. The one that caused us a little problems because it canceled out one of our solutions was reducing in the numerator. But so long as you check the x equals 0, you'll be okay. Or if you don't want to reduce at all, you don't have to. Sometimes, though, this one wasn't too bad to solve as a cubic, but sometimes they can be really tricky. So be careful. You may want to reduce to make something easier, and then it's easy enough to check x equals 0 as a solution. All right. If you have any questions on this one, ask me in class on Monday. All right, so let's take a look at this one. All right, this one really makes sense to reduce. It will not eliminate a solution because where we want to reduce is in the denominator. So 0 can't be one of our solutions if it's going to be in the denominator anyway. You can see there's no way you can plug 0 back into this, right? X minus 4 would be over 0. Right, so very clear. And over here you'd have 0 squared minus 3 times 0. That's 0. So definitely we want to cancel out one of these x's. And it will give us something much easier to solve. You won't be multiplying x squared minus 3x times x minus 4. So first of all, let us factor. That will be our first step. So we have x minus 4 over x equals 6 divided by, we'll pull out the x, and we have an x minus 3. The only thing that reduces, because I don't have an x minus 4 anywhere, but one place, I have one x minus 3. I have one constant, so there's no other number there I can reduce 6 with. But I could reduce these. And actually, it's going to take out our extraneous solution. So we're going to have this will just be a 1, and this is just now an x minus 3, and we're going to have something much easier to solve. So now I have x minus 4, so I should probably write our steps. So now we factored, we reduced, we're going to cross multiply, so we have x minus 4 times x minus 3 equals 6 times 1. Right, when we multiply, x times x is x squared. The outer terms, x times negative 3 is going to be negative 3x. The inner terms, negative 4 times x is negative 4x. And the last terms, negative 3 times negative 4 is positive 12. Or you can write that as a distribution. X times x minus 3, negative 4 times x minus 3 equals 6. Let's combine our like terms, and why don't we just subtract the 6 at the same time? So we have x squared, I should probably cross multiplied, and we're going to set our equation equal to 0 and factor. Okay, so we have x squared. This will give us a minus 7x, and this is going to be a plus 6 equals 0. So 1 times 6 is 6, two numbers that multiply to give us 6, add to give us negative 7, and hopefully you're all shouting negative 6 and negative 1. Those are the two. So we have x squared minus 6x, and then plus negative x plus 6 equals 0. We can factor out an x, and we have x minus 6. We can factor out the negative 1, and we have x minus 6. And our two factors were x minus 1 and x minus 6. And so now we just set those equal to 0 and solve. Put it over here. X minus 1 equals 0, x equals 1. And if x minus 6 is 0, x equals 6. So we have two solutions to check. Right? And the one that we canceled out, the x, would have definitely been extraneous anyhow. So it was good to cancel him out. So this is a really good one to reduce on. Right? I think maybe I put the check on this page because it takes me, oh, I did. And I kind of need some space. All right, so I am going to, as I'm taping this, I'm going to clone the page. And let's do the check. And that's going to be the last thing. All right, so I'm going to get rid of all this. So we have some space. We'll get rid of this. And we're just going to keep our two solutions, 1 and 6. There, come on up. And whoops, well, I guess they don't want to come up. There they go. They changed their minds. All right, we'll plug those in and see if they work. All right, so we have 1 minus 4 over 1 equals 6 divided by 1 squared minus 3 times 1. So 1 minus 4 is negative 3, and divided by 1, that is negative 3. Over here we have 6 divided by 1 minus 3. That's going to give us 6 divided by negative 2, and that is negative 3. So that solution checks out. That one is a solution. I plugged in 1 and that worked. Let's plug in the 6. All right, so we have 6 minus 4 divided by 6 equals 6. 6 squared minus 3 times 6. 6 minus 4 is going to give us 2, and that divided by 6, which is 1/3. We have 6. Always make sure you reduce so you can tell that they are the same fraction or not. 6 squared is 36 minus 18. Right? And so that is going to give us 6 divided by 18, which is also 1/3. So that one checks out. They're both good. The one extraneous solution we would have had if we didn't reduce was the 0, but we already canceled him out. All right, so that's the end of this podcast and solving using cross multiplication. So in class tomorrow, on Monday, we will solve these problems. All right, bye for now.